All right. Hello, everyone. Thank you for finding the time to join today's Corundum developer meeting. Let's go ahead and get into it. All right, so I've got a couple of announcements real quick and then status updates. All right, so the next developer meeting hopefully will be the normally scheduled one on July 3rd. Although now that I say that, July 4th is the next day. That should be okay, I think. If it was on the 4th, that would be a problem. The next Switch developer meeting will be the week after, or the week before that, right? Next week on the 26th. Um, unless something changes. We'll see about that. Um, I guess possibly that'll have to be postponed. I'm not sure if Carlos will have enough stuff to talk about next week because he's actually going to be visiting UCSD for a couple of months this summer. So, in the preparations for that, maybe he won't have much to talk about, so we'll have to delay that. We'll see. We'll see. I got the meetings for the rest of the year marked down here, and there's also a link to the Google Calendar on the wiki page if you want to put it on your calendar. All right, so moving on to status updates. Submitted a paper to SIGCOM. Got a couple of details on that, and then I'm going to talk a little bit about PTM support and RTile support, which kind of go hand in hand to some extent, and then also just a couple of things to note about the White Rabbit NIC project out of Open Compute. All right, so I had to delay the meeting because we had the SIGCOM camera ready deadline, and we were working hard on getting that squared away. So earlier this year, we submitted a paper to SIGCOM that was accepted. So we just submitted the camera ready. Well, I guess the camera ready deadline was actually last week, but the week before we were all working to get everything all squared away on the draft for that. And basically what we did for the paper is we implemented, the RotorNet protocol on top of our, experimental optical switch. And we used Corundum to, make all of the host connections and do a lot of characterization and whatnot. So not only do we use it for the actual interface of the optical switch, but we use it for some low-level physical layer characterization, time resolved, BER to make sure the switch is actually working correctly. We also use it to implement the Opera indirection protocol, or basically doing time-based routing to indirect traffic through the optical switch. So we used a combination of the alpha data, ADM PCIe 9v3 FPGAs, and the Silicom FB2CG boards with the KU15P FPGAs. And there's a whole bunch of details in the paper about, the overall setup and, transceiver characterization, things you might need to think about in terms of the line protocols and the PCS layer if you're going to be doing, relatively fast optical switching. Some interesting stuff. Yeah, we added like 8 pages of appendices, so it's a bit of a read, but there's a lot of good stuff in there. So I'll just show you guys a little picture of the test setup here. This is the optical switch connected to some of the hosts that we have in the rack. So we use 16 hosts with, like I said, the combination of FPGA boards. Those are hooked up to the fiber ports in the back. So we've got 32 MPO connectors here. Each host gets 2 cables. So there's eight uplinks per host. And then this here in the front is the optical switch. We've got the actual switch disk over here, which is diffraction gratings patterned onto a hard disk platter. So we synchronize the rotation of that with the data flowing out of the hosts. And then on the other side of this, we have a little micro-optic prism array that's used to actually form the network connections. So light comes down the tube from the hosts, bounces off a mirror here, bounces off the rotor disk, ends up in one of the matching patterns here, then makes a second trip bouncing off the rotor disk back down the tube and to a different set of hosts. So a lot of work to get this switch built and to get the whole system operational. And now that that's done, then we've submitted to SIGCOM, and that'll be appearing in August. Oh, geez, I got to book my ticket for that. Anyway, that's all I have to say here. Probably will. If you guys are interested in that, you can take a look at the paper or ask about it later or whatever. It's some interesting stuff there. All right. So moving on to status updates for Corundum itself. So Corundum for quite some time has supported, PTP time synchronization and PTP timestamping. I'm thinking about adding White Rabbit support to it. There's still a lot of work that needs to be done on that front. But all of these protocols, they only operate on the network side, right? You can sync the NIC clock to stuff over the network using these protocols. But the question is, how do you take that NIC clock and synchronize it with the host clock, right? Either way, if you want to synchronize NIC clock from the host clock or the host clock from the NIC clock, that's a totally different ball game because that has to run over PCI Express. And PCI Express is also a packet switch network. So the TLPs that encode the operations, those also get stuck in queues and, undergo various latency variants, which, it's not necessarily a huge problem if you're just transferring data, but that variable latency ends up being a huge problem if you want to synchronize the time between, the NIC and the host. So the question is, what can you do about that? Well, not much, right? You have to actually change PCIe to fix that. And standardized in PCIe, I don't know, Gen 5 maybe? This is a pretty recent thing. They added something called PTM, and this is basically PTP for PCIe. So PTM is precision time measurement, and it to use it, you have to, in hardware, exchange the synchronization TLPs, right, the PTM messages, and those are going to be hardware timestamped by every component in the system. And it basically works like PTP and enables, well, it basically uses PTP boundary clocks at all of the PCIe switches. And this enables a, a host's notion of time on the CPU to be transferred to the PCI Express devices. And now, right on the card, you'll have both the host notion of time and the, local clock that you've synchronized via PTP or White Rabbit or whatever, and then you can compare those and figure out, who's running faster or slower and make the appropriate changes on the host end. So this basically removes the variable latency of the MMIO operations from the picture. So what is the roadmap for supporting PTM in Corundum? Well, PTM, like I said, it requires hardware support, and that tends to be handled in hard logic on a lot of these devices. So on the Xilinx devices, as far as I'm aware, no Xilinx devices have native PTM support, unless there's something really new that got released recently that I haven't looked at in detail yet and don't have a dev board for. There's no device I'm aware of that has PTM support. But I think it's possible to implement it in soft logic, although it's going to take a fair amount of work because, you have to be able to at least extract and timestamp these PTM messages and also send them. If you can't send them, then we might have a problem. But we got to be able to timestamp them both coming and going. That's the main thing that needs to be implemented in order to get performance. But I think that should be possible because in all the Xilinx devices, at least setting aside some of the Versal CPM stuff, where it is all done in hard logic, you do have access potentially to the connections between the serializers and the PCI Express hard IP core. So somewhere in there, it should be possible to get access to the TLPs and do what needs to be done for PTM to work. For Intel cores, it's kind of a similar situation where nothing except for the latest Agilex I-series devices with the R tile, nothing supports PTM. But unfortunately, on the Intel devices, everything's all totally hardened. You can't access anything between the serializers and the PCIe hard IP core. So it's not going to be possible to add PTM support on most of those. But the R tile natively supports PTM. So if we have an I-series dev kit, then we should be able to use PTM more or less out of the box. So that brings me to the actual plan here. Short term is to take Corundum, port it over to run on the R tile, and then integrate the R tile native PTM support just so we have an example of PTM running and we can make sure it works correctly and all that stuff. And then the long term is to develop soft PTM support for Xilinx Ultrascale Plus devices. Unfortunately, this is not a trivial task because we need to be able to extract the PTM TLPs on both the RX and TX pads for all the rates, Gen 1, Gen 2, Gen 3, and probably Gen 4 as well, and all link widths, right, all the way up to by 16. We only care about the PTM messages though, so that simplifies things. So we don't have to care about, really long messages. We don't have to care about, link layer stuff, just the PTM TLPs. Now, I know there was an effort to put together PTM support for Arctic 7 on the time card, but it only supports like a Gen 1 by 1, as far as I'm aware, and it also might be subject to queuing delays within the hard IP core. Not 100% sure about that. That'll definitely be one of the things that I'm looking at for, implementing PTM properly, is to make sure that, we're timestamping stuff on the series side to make sure that it's going to be accurate even under load. So the time card, they don't have to worry about that too much because, it's just timing. But for Nick, you're going to be potentially exchanging a lot of data over PCI Express. So that it's important to get that right. So I don't have a timeline for the long-term part of this, but short-term, I have an I-Series dev kit. So hopefully within the next few months, we'll be able to get this thing working.
Alex,
Yeah.
I guess there is on the Intel side, on the Agilex 5, I guess there might be support for PTM as well because they changed the architecture again and
Right.
they
Yeah.
don't have tiles and it's all built in uh the single die
Yeah, I guess that'll
monolithic
be something to look
design.
at. I guess those are slightly lower end parts. I don't have a dev kit for one of
Yeah,
those, so as soon as I can get my hands on
well,
one, maybe we can take a look at that. But
we do, and we might get one to you as well. So I'll hook up with
all
the
right.
Arrow guys that sit on those.
What are the capabilities of those dev kits? Is that like a nice PCIe form factor thing, or
Nope. It's more like the ZCU 106 kind of form factor.
okay, so it does have some PCIe, but it's not a small
Yes,
one, it's a big one.
it
Okay.
it's a PCI Express card, but it's not compliant and it's too large and in the direction where that you can't fit the
Well,
lid
right, but
on.
at least it's a decent thing for developing,
Yes. Yeah.
Corundum. And it's got some high speed like SFPs or QSFPs or something, right?
I think it has two SFPs. It can definitely do 10 gig. Not sure if they can also do 25 gig. But it's
Okay.
very
Well,
early toolchain support for it in 24.1, I guess. So I guess probably wait a little bit for better support.
yeah. Yeah, that what's new? Yeah. All right. Well, we can certainly discuss that. Yeah, I haven't looked at the latest stuff. I just know the RTile supports it on the Agilex I devices. Those also support up to PCIe Gen 5, which that could also be interesting. But yeah, the Agilex 5 ones, well, I think those are almost a little bit more like Zinc devices, right? They also have a bunch of hard cores and things like that, or maybe
Yes.
they have a variety
Yes.
of the different parts. Okay. Yeah, so there could be some interesting stuff to play around with there. I just can't do much without a dev board, unfortunately. Anyway,
100%.
moving on to the RTile roadmap. So if we're going to implement PTM on the RTile, well, we got to get the RTile running in the first place. So the RTile, it's similar to the PTile, but it has a number of important differences. The first one is that the RTile supports all the way up to Gen 5 by 16. So that means they had to double the internal interface width to 1024 bits instead of 512 bits. Um, the interface, the streaming interfaces otherwise are very, very similar. I don't think there's any, I gotta double check. I don't think there's any significant differences in terms of how the headers are transferred and whatnot. But the big difference is that the flow control is different. So I gotta sit down and figure out how the flow control credits work between the RTile and the FPGA in order to make this work. But the interesting thing about the RTile is it supports Gen 4 by 16 as 1024 bits at 250 megahertz, which is quite interesting because on the P-tile, 4 by 16 is 512 bits at like 500 megahertz, which, yeah, the timing closure for that is not going to be straightforward. But, 4 segments, 1024 bits total at 250. This is within the realm of doability, I think. but we'll see. It's probably still going to need some work to make that operational. So the plan that I have here is first to get either Gen 3 by 16 or Gen 4 by 8 working. Whatever is, 512 at 250. Mainly need to get the flow control sorted out for that. Once we get that working, then the plan is to get PTM operational so we can get the time synced versus the host and get that exposed through the register space and synchronized with the internal, PTP hardware clock components. And the medium term would be to move to Gen 4 by 16, which would require supporting the 1024-bit data path width instead of 512. And then the long term is maybe to get it to work for Gen 5. I don't know if that's going to be feasible, but we'll see because we really got to crank up the core clock frequency for that to work. They actually have several options. You don't have to go all the way to 500, but they got like 350, 400, 450, something like that. You can pick from a few different ones. So it's possible that going to one of the lower clock rates might enable something to work, but without totally rewriting everything. But we'll see. Either way, we're looking at some pretty wide internal data paths, so that could cause problems in and of itself. That's kind of what I'm looking at here in terms of the RTile support. Now, obviously, to make this work, you don't only need the dev kit, but you also need a CPU that supports at least PTM, although ideally also PCIe Gen 5. So I guess weekend before last, I actually went up to San Jose and I met with Ahmad at Meta, who's spearheading the time card project for Open Compute, and he provided a Sapphire Rapids motherboard and CPU. And previously, I had requested and eventually received an Agilex iSeries dev kit from Intel. So I now have all of the pieces needed to make this work, at least from a hardware perspective. Now the only thing I need is some time to actually sit down and hammer it all out. But assuming all this works, we might be demoing something at the OCP Summit and possibly also ISPCS later this year. So that's if you're planning on attending one or the other of those, maybe we'll see you there. I think that's all I got. Oops. Oh, I got one other thing. I hit the wrong button here. I got one other thing, which is the White Rabbit NIC. I think we uncovered one potential problem on the associated with the PCI Express reset line. Apparently, the PCI Express spec doesn't allow you to put too many pull-ups or pull-downs on that line, and some motherboards, they basically tie all the reset lines together as far as I'm aware. So if you have too many pull-ups or too many pull-downs or something, then it can actually affect other devices. Motherboard dependent, I suppose. From looking at a bunch of the existing dev boards from Xilinx, Intel, everybody, there's quite a few that definitely are implementing things incorrectly. So, yeah. But a lot of them, interestingly enough, don't have any pull-ups or pull-downs at all, which I guess is kind of what the PCI spec is going for, right? They have, can't remember what the spec is, but it's like a few microamps or something like that that you're allowed to source or sync, and if you go above that, then it's potentially going to be a problem. So, yeah, I think on the board that Julian laid out, I think we had like 2 5K pull-ups or something. Definitely a little bit too stiff. So I can't remember if we pulled those off or we'll just pull them off manually, once the thing comes back from fab. But the second revision of the board has been sent off for fabrication. I'm not sure when that'll be done. I should follow up with those guys and check. But hopefully that'll have most of the bugs fixed from the previous revision. And if that looks good, then we'll probably add support for that upstream. Yeah, I don't want to add support for something where you got to add like 10 blue wires and move around a bunch of resistors in order to make it work. So, yeah, hopefully this will be done soon. And if we do have this working to the point where, we can demo it, then it'll probably also appear at ISPCS and or the OCP Summit. So, yeah, that's about all I got in terms of status updates for now. If anyone has any questions or comments about anything, Fire away. Also, I guess I can also show off this little thing that I've been working on here. This is what I've done with the with that motherboard that Ahmad gave me. It's like a micro ATX form factor, so I got the smallest computer case that I could. This is like small enough to fit in my carry-on luggage. So, yeah, hopefully we'll be able to get that over to the to both those conferences for demos, so we actually have something to demo. But yeah, this I have the Agilex I series dev kit in here. So, like I said, I think I have all the parts now for getting PTM working. Just need to sit down and figure out all of the flow control stuff. Okay, does anyone have any questions or comments about anything? Well, look, what was the part number on that Agilex 5 board? Said that was from, let's see.
The Arrow Eagle board.
Arrow Eagle.
Yes. But I will
Okay, I found it. I found a picture of it. I see. So it's got a bunch of, oh, they got a bunch of USB 3 ports on there. That's interesting. Well, I guess it's more of an SoC part, kind of like Zinc,
yes,
right? So they got
exactly. Yeah.
a lot of that sort of thing. Oh, and a big FMC plus. Well, I guess it's actually not Intel anymore, right? They're Altera again.
Yes, they are all Altera again. And this board, well, it's the support is in a pretty early stage. So
Right, yeah.
we tried to put something together for Embedded World this year, which was in April. And basically just 1 week before the show, the required Quartus version popped out. So there wasn't anything possible to demo on that.
Yeah, that's not a lot
Um,
of time, is it?
yeah, not really. And there was no example design for PCIe, no example design for Ethernet or nothing. So yeah, you can't tweak all things out in 1 week.
Yeah, yeah, you might be able to figure one of them out, maybe. Assuming you don't
Maybe.
need to do too much tool wrangling. But yeah.
Yeah, but you know, if the lock status signal of the PLL is hardwired to 1 in the generated core, so you know something's not very well tested, right? Um,
Oh man.
so things
That's not a
happen
good
to
sign.
be exactly. So we sorted some things out, but everything is very early. So that's how it is, right? So nothing bad, but the usual things.
Right, right,
So
yeah.
it should be better by now. Um, yeah, so I guess I see how we can kind of get a board to you and maybe speed this up a bit. So people are aware of it. People are aware that it might be a good idea to get Corundum running on it. Um,
Yeah, well, we should
yeah,
certainly discuss that. Don't have to discuss it now, but yeah, I'm just looking at the
exactly.
specs for this thing. It looks like it has some series at 28 gig and some at 17. But the datasheet, or this page I'm looking at has a block diagram. It's only listing the SFP pluses as 10 gigs. So I guess the 25 gig series must be hooked up to something else. I'm not sure.
I guess it depends on the parts, I think. At least for Stratix 10, it was part dependent and voltage dependent. And there is
Right.
speed grades for the transceiver tiles as well. Well, there is no
Yeah, that's
tiles
true.
in this device, so maybe they still have different speed grades for transceivers. So we
Right,
need to
right.
see.
So do you know, are these devices like closer to the Zinc devices where they have a lot of dedicated SoC IO, or are they more like some of the other Intel devices which have an SoC but don't, at least as far as I'm aware, don't have a lot of dedicated IO? As
I don't
in,
remember.
you can ignore the SoC and still use pretty much everything if you want.
Yeah, no, I think in this case it's more like Ultrascale Plus rather than 7 series.
Right,
So
okay.
you need more to take more care about, especially from a boot perspective. You need more, you need to take care more about the processing
Okay,
subsystem.
so it boots more with the HPS stuff first as opposed to the FPGA first. Because my
Yeah, I think
understanding
so.
is that there's a bunch of like the Stratix devices that have the HPS in there. Like I think even this Agilex I series dev board that I have here has an HPS component to it. I could
Hmm.
double check on that. Could be wrong about that. But even when it has it, you can basically just ignore it and it boots normally.
Yeah, because they
Um,
use the SDM for configuration, right? So they have this other
oh, that's a
soft
good
core in
point.
there.
Yeah, that's a good
It's not a
point.
soft core
You
actually,
can't
so
really
it's
avoid the
another
SDM.
subsystem.
Okay. Yeah.
Yep, you can't. Yeah.
Yeah, I think this iSeries dev kit has the same problem that a lot of the other Intel boards do. Is and there's another FPGA on there that sits between the big FPGA and the flash, so it's impossible to do the in-band PCIe firmware updates
Uh,
because you cannot access a flash even if you want to. Um, I don't know why they design all their dev boards like that. It's a pain in the butt. I mean,
it is. Yeah.
it'd be one thing if they like put two flash chips on there, one you could boot from directly and one that, you got to go through the streaming interface or whatever from their secondary FPGA. That would be nice.
Yeah.
But no, they can't
I
even bother with that.
I'll provide another interface to this FPGA to talk to the flash. It would be okay if it's indirect, right? So just, I don't
Yeah,
know, any path.
yeah, yeah.
Uh,
Well, I mean, it's the kind of thing where if you wrote a new firmware for that Max 10 FPGA on there, I think, then you might be able
mhm.
to abuse some other connection. There are like some I squared C interfaces that both are connected to, but they don't really provide any additional wires for that or even provide the source code for whatever the heck is running on that. So it's like, okay, great.
Yeah,
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 I don't know.
that
I don't know
that's
what the
how it
deal is with
is.
that. It's like basically every Xilinx dev board works more or less the same way. There's a couple of exceptions to that, but for all of them, for pretty much all of them, you just directly talk to the flash. All the Intel ones, with very few exceptions, they have that freaking Max 10 FPGA in there. And then the other annoying thing is that when they do provide some other interface to the flash, it's always like some board specific proprietary thing. So either you
Yeah,
can't update the flash at all, or it's some board specific, you know, got to jump through a bunch of weird hoops to make it work.
yeah,
I
like
guess
the
they're
bit
just trying to
where
force people to use the whatever you call it. Um
those
Basically the
shells
where you
or
do the yeah, I guess Intel has better support than than Xilinx where the FPGA bitstream in Flash only brings up the PCI Express interface and then you load the rest of the design over PCI Express.
CVP,
Yeah, CVP. I was like, what the hell is the acronym for that? Yeah, CVP.
configuration via
I
protocol, I guess is the
hate
name.
that. Hate it. Makes all the logistics 10 times more complicated.
Hmm.
So you got a perfectly good flash on the board. Why don't you use it?
Yep. Yeah, and you need to at some point there might be a problem in your initial design bringing just up the transceivers as well. So
Well, right. Yeah. I
uh,
mean, the other thing about all this stuff is that now you have some weird tool version dependency between, whatever you're building your new design with versus whatever's running in Flash on there. And then if that version is wrong, well, how do you update it? You know, got to pull out a USB cable and reflash the damn thing. You can't just do it in band. Uh,
yeah,
and I
there
think there's
might
some weird
be.
stuff possibly related to the SDM as well, because I seem to remember. 'Cause 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 I seem to remember. At least
Yes.
on one of the other dev boards I was looking at, like when you boot the thing up initially, it'll reload the SDM firmware from the flash. And then depending on what's in that firmware, the tool may or may not be able to talk to it. So there was like some for one of the boards, there's like some recovery procedure of how you get the thing to not boot from flash, and then you can,
Hmm.
I guess, do an initial flash with just to get the thing into a slightly operational state. It's like, okay, why does
So
Intel have to make this so darn complicated?
yeah, there is an option you can select in the SDM configuration, and you can then direct or dedicate a pin to doing factory boot, I guess. And then you direct it to load a special image at a specific flash address.
Yeah, so how does that
Um,
even work in these boards where you have your max 10 FPGA? Because the SDM can't even see the flash. It's like
Good question.
it's like
I don't
they
know.
built like two layers of security into these things. They got the SDM thing, which its whole point is to manage the device, and it has all these fancy features. And then they add this max 10 FPGA, and now with the max 10, it kind of neuters all the features or maybe not all, but a lot of the features of the SDM because it can't even talk to the flash. It's like, ish, why do they do that? I don't know.
Yeah, maybe it's just that people did put in the past stuff into the Max 10 that is now part of the SDM, and but they still just reuse the old design because they know it. And
You know,
it's all
probably
proven.
what's going on is they have the same guy that's been designing all of their dev boards for the last 20 years.
Yeah.
He puts the Max 10 on there just as a rule. And then everybody else that makes a clone of the board just copies the same design. And the only boards that are different were designed by somebody else.
Yeah, so we
I
don't
think the
have a
only
Max
board that
10
I'm
in
aware of
there.
that's different is like the Stratix 10 MX dev kit, which is actually directly connected.
Oh, it is. Okay. Yeah. So our board also is directly connected.
Which is great.
And we can and we can do flash updates and it works. Yeah.
Yeah, that's cool.
Yeah.
Oh, and I guess I don't know if I posted this to the group. But apparently the MLE guys now have their board listed with Krenz. So if you want to buy it, um, it's available. They sent me a link, right? I could probably hunt that down.
Yeah, I can post it in Zulab as well. I guess we have a board section somewhere.
Yeah, or you can just post it in yeah under boards. That would work.
Yeah.
I don't know if that's something people are interested in. I don't know.
And I actually did invest a bit of time and ported our old, well, based on a, I don't know, 1.5 years old Corundum design and provided and updated it. And so I now have current Corundum running on this board attached to the driver. Just need to fill out using the board EEPROM because it's
You have a different
not
layout, I guess.
compatible. Nah, it's not compatible with the SM bus infrastructure because it uses 2 byte addressing, and I wish we
Oh,
had just
right,
put a
right.
small
Yeah.
EEPROM, but we we
Yeah,
we
I
we
mean, I
thought about.
think, yeah, I guess my philosophy for that has basically been if the board doesn't use an EEPROM that can be used at the SM bus thing, then I'm just gonna punt on that until we have a microcontroller, a soft core that can handle that sort of stuff.
Yeah, there might be a different approach. So there is the 8025 24 driver that can do both ways of access, and maybe we
Right,
can
yeah, yeah.
just switch over
Yeah,
with everything to this. But it's a pretty much more complex way of representing an EEPROM. And yeah,
yeah.
we need to
So
look at it.
the annoyance that I have about all that stuff is that it's all designed for if you have the CPU directly talking to something. It's not really designed to
Mhm.
be set up as a, peripheral component of some other peripheral device. And there seems to be
Yeah,
kind of no way of making that work nicely, which is kind of a pain.
yeah, seems so. So we managed to make it work with an older kernel version, but it kind of something broke. So it still compiles, but it doesn't work anymore. So we need to check. So we have code that actually runs and uses the MAC addresses within this EEPROM. So it should be working, but it needs to be updated. And once this is done, we could provide a pull request for it, and then we could also provide the software portion to do the flash update. So I did test accessing the SDM. That still works. So my tool still can talk to it, and so I just tested to read out voltages and temperature, which you could also do via the same interface.
Gotcha.
And yeah, so I didn't especially retest the flashing procedure, but we'll do this later this week. So yeah, might be interesting as a starting point, port this to the MX dev kit as well.
Right. Yeah. I mean, I guess they must be using a similar setup on there. So, the more you can recycle, the better.
Yeah. So especially the interface to the SDM might be interesting. So it's kind of a mailboxing thing.
Right.
Yeah.
All right. Well, it would definitely be interesting to get access to one of these Agilex 5 boards, although I guess it's always a question of, even if you send me the board, I don't know if I'll have time to to do much with that. Um, but yeah, if it supports PTM, I guess I'll probably start with the Agilex I board, and then once we get the kinks worked out with that thing and get PTM running, then possibly it'll be a straightforward port onto one of the Agilex 5 parts.
It
But
kind of
yeah,
depends on what's more important, getting PTM running or the higher speeds or the specific enabling of the tile, right? I don't know if maybe the flow control is much more similar to the already supported tiles on the GLX5, so that might be interesting then.
it's kind of similar, but there's a few differences. It's more like I just need to make sure I have all the initialization procedures properly set up and everything for that to work.
Okay.
And I think like on the previous ones, they had slightly different schemes for incoming and outgoing, and for this one, they kind of unified it a little bit. So it shouldn't be that big of a deal, I think, to get it working. And then the higher speeds, that's kind of a long-term to-do. Hey, wouldn't it be great if we could run it, 200 or 400 gigabits per second? But yeah, it's probably going to take some time to get to the point where that's actually going to work. But at least with the I-series board, you have the possibility of doing that. So with these
Yeah,
things,
exactly.
with the Gen 4x4, I guess that's equivalent to a Gen 3x8. So not enough for 100 gig, but you could definitely do like 40 gig through that. Yeah, because it looks like I guess is that just a limitation of that particular board? It must be the board. Because they probably have more than they probably have enough transceivers to do more than 4 lanes of Gen 4 on the Agilex 5. I
Possible.
know the Cyclone 10 devices were limited to 4 lanes of Gen 2, even though their transceivers could potentially do Gen 3. And it definitely had more transceivers if you wanted to do like 8 lanes or something. You should be able to do that, but for some reason their hard IP core for PCIe was only 4 lanes of Gen 2. It's like, really?
Yeah.
Um,
But it's the same on signings as well, right? So the Vertex Ultrascale Plus, the transceivers can do 16 GT, but the hard IPs can just do Gen 3 by 16, not Gen 4 by something. So that's always the same thing.
Well, I mean, it's one thing to not run at the full speed, but they had both the speed limitation and they had the lane count limitation. Like, why are you
Okay.
limiting it to 4 lanes? Why can't you do 8 lanes or something? Yeah.
Yeah.
Well, so the thing is, the Xilinx UltraScale devices technically should support Gen 4, but there's I got the story from one of the Xilinx guys that basically they implemented a draft version of the Gen 4 spec on those devices, and then some optional feature was made required. So Potentially
Yeah.
they support draft Gen 4, but that only works on certain motherboards or whatever. So they ended up just,
Yeah, I
forgetting
think
that that feature ever existed.
technically speaking, you could support a higher speed without supporting the respective protocol version. So it's not the same thing, right? So talking Gen 3 does not necessarily mean you need to do 8 giga transfers or vice versa. So
Well, yeah, I mean, but if you're trying to
technically
talk to an
speaking, it's not the
existing
same.
standard device, yeah.
But yeah, most people, for most people, it's a synonym.
Right,
And you're
yeah,
right, most probably a lot of endpoints or root complexes, yeah, kind of are not interoperable, and yeah.
right. Well, I mean, if you download an old enough version of Vivado, you can actually try out Gen 4 on ultra scale devices. Or I guess not ultra scale plus, right? It's ultra scale plus, but not the um I like the HBM ones, they have a newer core, right? The PCIe 4C, but the PCIe 4
Mhm.
ones technically do support Gen 4. Ultra
Oh, okay.
scale, I don't think has a new enough core to support that.
Yeah. No, we
Well,
just
ultra
use.
scale, I guess, can't even do Gen 3 by 16, only does Gen 3 by 8. I'm not sure if that's a limitation. It's probably a limitation of the core, but
Yeah. So you can do more in soft cores, but
right. Yeah, I mean, yeah, you can always
yeah.
put a soft core on there and eat up half of the FPGA just for the PCI Express stuff. What are you gonna do?
Yep.
All right. Well, does anyone else have any questions or comments or things you want to discuss? If not, then I guess we can adjourn the meeting for today then. We'll see you guys in a couple of weeks.
All right, see you.
All right. Sounds good.
Great.
Talk to you.
See you. Thanks.
See you guys. Bye bye.
Talk to you.